Closures. While it makes our code easier to read and our functions easier to maintain, it is sometimes unnecessary. Take for example on the code on the screen. We have a closure named capitalize first letter, which gets recreated every time its parent function named getUserFullName is called. This is unnecessary because closure does not reference any value outside of its scope and can then be extracted outside of its parent function. From this, it will become this. Now this is useful because we will only create the function named capitalize first letter once. That is when the program starts. Unlike on the earlier version where it gets recreated every time the function named getUserFullName is called. This is also useful if you want this function to be used in other parts of your code base. It is possible that this function named getUser has a necessary implementation of a closure, but it can definitely be changed. Now this change name is a function that takes in a parameter of new name, and this references the database variable or parameter that was passed onto its parent function, which is named getUser. Now this function named change name now has access to the database value. Of course, this can be changed into something like this. As you noticed, we added more parameters to the function change name. However, this may be better because we separated the state or the information about the user in this function named getUser2 into separate kind of methods with separate functions, for example, named change name. However, in this change, we now need to pass on the database value and then the ID in the change name function. Whilst on the previous example, we only needed to pass the new name because it already referenced the database and the ID of the user. What is the difference between a shallow copy and a deep copy in JavaScript? Shallow copy means to copy an object only in its first level or the very surface level of an object or an array, while a deep copy means to copy everything onto its deepest level. Now, what is this level? Well, a level pretty much means an array that is nested or nested arrays or nested objects. Now, what a shallow copy does is that it copies the first level, so primitive values will get copied, and its nested arrays will get copied, but only the reference to the values of that specific array. This is because arrays are pretty much references to a primitive value. A reference means that it is pointing towards a value in memory. So if a value that is being referenced changes, the value in the reference also changes. Let's see this in action. We have the original array, shallow copy, and the deep copy of that array. If we check the results of the console, first we modified its first value, which is the 0th index. We turned 1 into 100, and its second value, which is the first index, which is a nested array, which contains the value 2. Okay, so we turned that, the second value, and changed its first value into 200. So we changed 2 to 200. Now if we check the console, you can see that the value of the original array changed from the first value being 100 and the second value's nested array being 200. However, on the shallow copy, the value of the first item did not change. Meanwhile, the value for the nested array changed. This is because the primitive values get copied, and these primitive values are strings, numbers, booleans, and such, while arrays and objects are not primitive values. This is because, again, they are references to its data or to the data inside of them. So for example, the array references the values of 1 and then its nested array, which contains a reference to the value of 2, and so on and so forth. Now, a shallow copy copies the first level. When it encounters arrays or objects, it copies the reference. So that's why when a value of this, for example, of 2 changes to 200, It also changes for the shallow copy, but for the deep copy, the values of the references of nested arrays also gets copied. It does not change because it is a new value in memory. And this deep copy method is not really recommended. If you truly need to deep copy, there may be algorithms that are better to use. So deep copy pretty much just does recursion, I think. And if you only need to copy a matrix, you can do something like const matrix. Let's say we have Copilot, do your thing. No, 1, 2, 3, and then there we go. You can do something like this. We want to map through the matrix and then shallow copy its rows. And we can just shallow copy its rows, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, because they contain primitive values and not nested arrays or objects. So this is fine to do right here, okay? And that's pretty much it for shallow copy versus deep copy in JavaScript. Now for the last example is how we can make our code more readable and easier to maintain. There are a few problems with the function named update username. First is that we are using hard-coded values. Now what does 10 mean? Well, based on what we see, it means the maximum length for a username. Instead, we can actually have that as a global constant. Const max user name length equals to 10, and the same for the minimum. And now we can add that inside of our conditions. Username length. And we can now reuse this in other parts of our code. The second problem is that we are actually nesting if conditions unnecessarily. We can do something called early returns, or in this case, early throws, and not using the else clause. And this else clause is unnecessary because we are essentially getting out of this function when we throw an error or when we return. So we can remove this and this as well. There we go. And that's it. Now this function looks much better than before. Of course, we can do some more checks wherein if, there we go, if new name is equals undefined, or if user ID equals undefined, or something like that. And I forgot one more thing, which is to make this asynchronous and await the operation. I hope you learned something. Thank you for watching and see you on the next video. Good luck on your development journey. Fun. God bless. Bye bye.